Hey everybody, and welcome to SpaceWeek for Monday, December 30th, 2019. I hope you all had a good Christmas, or at least a break if you're not into the Christmas thing. If neither, then perhaps New Year's? There were 3 launches last week from Russia and China. Russia launched a Proton rocket with the third elektro-l geostationary meteorological satellite. Each elektro-l provides 121 megapixel full-disk images of Earth, similar to Japan's Himawari 8, but situated along Russia's longitudes. Unfortunately for Russia, geostationary satellites have to orbit along the equator, so their view of Russia far to the north is quite oblique. The unnatural color is due to elektro-l providing data in infrared as well as visible wavelengths of light, which makes vegetation look rust-colored. Now if we could just get a Himawari equivalent in my hemisphere. Russia also launched a Rocket rocket with 3 more GONETS-M satellites and the first blits-m satellite. GONETS means messenger. GONETS D1M is a Russian civilian communications satellite constellation in low Earth orbit, based on the military Strela 3 system. There are now 16 GONETS-M satellites, the first having been launched back in 2005. BLITS is an acronym meaning Ball Lens in the Space. It's a small spherical retroreflector satellite, 22 centimeters or 8.7 inches in diameter, with a mass of 16.7 kilograms or 36.8 pounds. It's completely passive, with no electronics or power requirements. Its multi-layer glass sphere reflects light equally across a wide range of angles. The International Laser Ranging Service will track blits-m in order to validate the spherical glass retroreflector concept, to provide scientific data with sub-millimeter accuracy, and ultimately to improve the accuracy of the GLONASS satellite navigation system. China continued its end-of-year launch frenzy with the heavy-lift Long March 5 Y3 rocket, looking a lot like an Ariane 5. On board was Shijian-20, an experimental geostationary communications satellite. This was the 3rd launch of a Long March 5. The 2nd launch, back in 2017, had a problem in one of its first stage engines and failed to reach orbit. China has big plans for their biggest rocket. Over the next few years, they plan to launch 3 modules of the upcoming Chinese space station: the Chang'e 6 Lunar Sample Return Mission, the Xuntian Space Telescope, and SPORT, the Solar Polar Orbit Telescope to study the Sun's magnetism, coronal mass ejections, and solar wind. In other news, SpaceX completed their 10th consecutive Crew Dragon multi-parachute test, paving the way for next year's manned flight. Elon Musk also tweeted a short clip of the Starship Mark III tank dome production.
We're going.
Hopefully this one doesn't get blown off during a pressure test. On December 26th, viewers from the Arabian Peninsula over to Indonesia got to see a rare treat, an annular solar eclipse, which brings us to
the term of the week.
Annular simply means ring-shaped. The word is easily confused with annual, which means happening once per year. An annular or ring of fire eclipse happens when the moon passes directly in front of the sun from our perspective, but it's too far away to cover the whole face of the sun. Since all orbits are elliptical, not perfectly circular, and the moon's orbital distance from Earth varies by about 10%, sometimes the moon is closer during an eclipse, and sometimes it's farther away. When it's closer, we get a total eclipse. When it's farther away, we get an annular one. In the case of the December 26th eclipse, 97% of the sun was covered. I've personally only seen one eclipse, the North American total eclipse of 2017. It was perhaps the most breathtaking thing I've ever seen. I'm planning to live stream the next North American total eclipse in 2024. Meanwhile in Washington, President Trump officially established the U.S. Space Force when he signed the 2020 National Defense Authorization Act. The Space Force will be part of the Department of the Air Force, like the Marine Corps is part of the Department of the Navy. The Joint Chiefs of Staff will be expanded by 1 position, Chief of Space Operations. The first occupant of this role will be Air Force General J. Raymond. Joint Chiefs Chairman General Mark Milley said, "Our adversaries are building and deploying capabilities to threaten us, so we can no longer take space for granted. The U.S. Space Force is the necessary and essential step our nation will take to defend our national interests in space today and into the future." At the signing, the President remarked, "It's a big moment. That's a big moment, and we're all here for it. Space? Going to be a lot of things happening in space, because space is the world's newest warfighting domain. Amid grave threats to our national security, American superiority in space is absolutely vital, and we're leading, but we're not leading by enough. But very shortly, we'll be leading by a lot. The Space Force will help us deter aggression and control the ultimate high ground. Indeed. On a side note, I have to say, look at that Coast Guard guy in the back. Good grief. I think he may be the grandson of B.J. Blazkowicz. Over the past few weeks, the star Betelgeuse has looked visibly dimmer than we've seen in the last 50 years of observations. While we know it's a variable star, the magnitude of this dimming has some people speculating that it might go supernova soon.
It's showtime.
Betelgeuse, also called Alpha Orionis, is a red supergiant star, one of the largest and brightest visible to the naked eye. It forms the left shoulder of Orion as seen from the northern hemisphere, or his right foot, I guess, from the southern hemisphere. It's only 15 to 20 times the mass of our Sun, but Betelgeuse is 600 times wider and more than 200 million times the Sun's volume. If Betelgeuse sat at the center of our solar system, all of the inner planets would be engulfed, and it would stretch beyond the asteroid belt, possibly even past Jupiter. Interestingly, although the core of a star is many times denser than diamond, the average density is much less, and the outermost layers, such as the photosphere, are little more than a hot vacuum. While the Sun's average density is about 1.4 times that of water, Betelgeuse's is only 0.009 times that of water. That's because its relatively moderate mass is being averaged over such a huge volume. As one of the biggest and brightest supergiant stars, Betelgeuse emits huge amounts of radiation, visible, infrared, etc., and as a result will have a very short stellar lifespan. Our Sun has been shining for 4.5 billion years. It has another 5 billion years until it runs out of hydrogen, and then 2 or 3 billion years after that until it dies completely. Betelgeuse, on the other hand, is only about 10 million years old. The dinosaurs had already been extinct for 55 million years when Betelgeuse first started fusing hydrogen into helium. Studies predict that sometime in the next 100,000 years, its core will collapse and it will go supernova. It won't endanger any humans that are on Earth at that time because Betelgeuse is 643 light-years away, more than 10 times the minimum safe distance for supernovae. But when will that happen? Today? Tomorrow? In 100 millennia? Like so many natural phenomena, we can only make educated guesses. We currently have no way to know for sure. We may, however, be able to get a few hours of warning before the light from a supernova reaches us. When a star goes supernova, in just 10 seconds it releases up to 99% of its energy as an enormous blast of neutrino particles. These are subatomic particles with almost no mass that travel very close to the speed of light. Because neutrinos rarely interact with other matter, they're able to escape the exploding core of the star before the light does. Unfortunately, since they rarely interact with other matter, that makes them difficult to detect. Supernova 1987A in the Large Magellanic Cloud only resulted in 25 neutrino events across 3 detectors. These days we have more and larger detectors around the world, including the 7 members of the Supernova Early Warning System, or SNEWS. The largest of these is the $279 million Ice Cube Neutrino Observatory at the South Pole in Antarctica, constructed from 2005 to 2010. Its 86 strings of sensors are distributed across 1 cubic kilometer between 1,450 and 2,450 meters beneath the ice. That's 0.9 to 1.5 miles deep. On Saturday, December 28th, our favorite rock climber-turned-astronaut, Christina Koch, set the new record for longest single spaceflight by a woman. Christina launched up to the space station back on March 14, 2019, and she's not leaving again until February 2020, a total of 335 days. The previous record was 289 days, set by Peggy Whitson in 2017. Peggy honored Christina with a special zero-G message from the infamous vomit comet.
Congratulations, Christina, on breaking the single flight record for a woman. I'm very happy for you. We all know gravity sucks.
Looking ahead to this New Year's week, there's not a lot going on. There may be a Falcon 9 launch with the Starlink 2 batch of broadband internet satellites. It was initially scheduled for December 30th, then moved to the 31st, and according to spaceflightnow.com, it's currently scheduled for January 3rd, though the time seems a bit confused. They have it listed at 11:20 p.m. Eastern, 3:20 a.m. GMT, but that's only 4 hours different. Eastern Standard Time is 5 hours behind GMT, so maybe it's 10:20 p.m. Eastern or 4:20 a.m. GMT. Whenever it launches, you can catch the live stream right here on Raw Space. Other than that, there's nothing on the calendar until January 16th. The calm before the storm, maybe? We shall see. That's it for this week. Thanks for watching. As always, feel free to like, subscribe, and activate notifications if you don't want to miss anything. If you enjoy content like this and you'd like to help out, there are Patreon and PayPal links in the description. SpaceWeek is also available as an audio podcast at rawspace.podomatic.com and on iTunes at tiny.cc/spaceweek. See you in 2020 and have a great new year.